All right, welcome to The Explainer. Today, we're diving into a huge challenge for anyone on a construction project. How do you keep your most critical, high-tech gear safe and sound in what's got to be one of the toughest environments on the planet? So let's get right into it. On one hand, you've got these incredible, precision pieces of equipment, drones, sensors, you name it, and they're absolutely essential for a modern project. But on the other hand, you've got the pure, unpredictable chaos of an active job site. And this isn't some theoretical problem, right? This is the high-stakes balancing act that project managers are dealing with every single day.
So, here's how we're going to break it all down. First, we'll look at that core paradox of the job site. Then, we'll dig into the real cost of equipment failure, the domino effect. After that, we'll talk strategy, matching the right protection to the right gear. And I'll let you in on a little secret. It's what's inside the case that really makes or breaks it. Finally, we'll put it all together.
Okay, so first up, let's really unpack this fundamental conflict, this paradox of the modern construction site. It's a world of what you might call controlled chaos, but the very technology that helps control it, it demands absolute stability and precision. So how on earth do those two things even coexist?
Just think about it for a second. The exact gear you rely on for critical data, for safety, it's constantly being threatened by the environment it's in. And that's why just grabbing any old box and hoping for the best isn't a strategy, it's a massive gamble. And when that gamble doesn't pay off, you're looking at downtime, painful project delays, and some seriously high replacement costs.
And that failure, well, it triggers a domino effect. Because when a critical piece of tech goes down, the cost is never ever just about replacing that one device. It kicks off this whole cascade of problems that get very expensive very fast. The thing to realize is that these threats aren't just random bad luck. They're constant and they're predictable. You've got the environmental stuff like rain, dust, mud, you name it. Then there are the mechanical risks, drops, bumps, and those constant heavy vibrations from machinery. And of course, there's just the day-to-day operational hazards of moving gear around. Without a solid plan, damage isn't just a possibility, it's pretty much an inevitability.
And this is where it really hits the bottom line. That one little broken sensor can literally bring an entire crew to a standstill. That drone that's down for repairs, it can delay crucial survey data, which stalls the entire next phase of work. That's the domino effect right there. One small equipment failure creating a massive project headache.
Now, the good news is there are objective ways to actually measure protection. These industry standards give us a common language. So an IP rating tells you how well something is sealed against dust and water. An IK rating measures how well it can take a hit. And MIL's DD-810, well, that's the US military's benchmark for surviving extreme conditions. These aren't just a bunch of random acronyms. They're your guide to choosing the right level of defense. So what's the answer? How do we fight back against all this chaos? Well, the secret isn't finding some magical one-size-fits-all box. No way. It's about tailoring the protection to the specific piece of equipment and, just as importantly, how it's actually being used out there on the site. Let's look at a few examples. For something handheld and portable like a drone or a survey tool, you're going to want a super robust, high IP-rated case with foam that's custom cut to fit perfectly. But for, say, a rack of sensitive electronics, that's not nearly enough. You need a shock-mounted case, something with vibration isolators built in. And for a huge, heavy generator, we're talking about a custom-built crate, maybe with its own internal climate control. See, it's always about matching the solution to the problem.
Okay, but now let's go a level deeper, because this is important. The outside of the case is really only half the story. The real secret to success, or failure, happens on the inside.
And honestly, this is where so many protection strategies just completely fall apart. You can have the toughest, most rugged case in the world, but if the equipment is rattling around inside, or the foam isn't right for the weight, or moisture's building up, guess what? You're still going to end up with a broken piece of gear. The interior is what turns a simple box into a true, fail-safe protection system.
Take foam, for example. You'd think foam is just foam, right? Nope. Soft polyurethane, or PU foam, is amazing for absorbing shocks on lightweight, delicate items. But for heavier, blockier equipment, you absolutely need the firm support of polyethylene, PE foam, to keep it from shifting around and to properly bear that load. Using the wrong one is just a recipe for disaster.
And it goes way beyond just foam, too. Advanced systems use things like elastomer blocks or wire rope setups to actively cancel out those damaging vibrations. They can have desiccants built in to suck moisture out of the air, or special materials that literally stop corrosion before it can start. You can even get modular interiors that you can reconfigure for different tools, which is super efficient and cuts down on waste.
Okay, so how do we pull this all together into a strategy that actually works every time? The key is to stop thinking about protection as an afterthought, something you buy off a shelf, and start treating it like what it really is, a professional engineering process.
A truly fail-safe solution follows a really clear path. It starts with a deep dive, an analysis of your equipment and its entire journey. Then you move into custom design and engineering. And this next part is crucial. You have to validate that design with real-world tests, drop tests, vibration tables, water ingress tests. Only after it's proven to work does it get rolled out. And it doesn't even stop there. Good lifecycle management makes sure that solution keeps working for years to come. This is how you go from just guessing to actually knowing your gear is safe.
So, ultimately, it all comes down to this. When you make that shift from just reactively buying cases to proactively building a protection strategy, the whole equation changes. It stops being this nagging, reoccurring cost for replacing broken equipment. Instead, it becomes a smart, strategic investment in keeping your project on time and on budget.
Look, in today's high-tech construction world, protecting your gear is totally non-negotiable. It's a given. So the real question isn't if you should be doing this, but how quickly you can get started with a solution that's been professionally engineered and is actually proven to work.